This lecture is about the thoracic anatomy. We're going to start with an aortogram. And so this area here is considered the root of the aorta. This is also where the aortic valve is. Um, the, the root of the aortic has a right cusp and a left cusp. The right cusp is where the origin of the right coronary artery is. The left cusp is the origin of the left coronary artery. And there also is a posterior cusp. And the posterior cusp is also sometimes called the non-coronary cusp because there's not a coronary artery that comes from it. The coronary arteries, of course, are the arteries that supply the blood, or I'm sorry, supply the heart with blood. And this area, again, at the root of the aorta and around these cusps, that also is sometimes referred to as the Valsalva sinus. And so if they're talking about the Valsalva sinus, it's referring to the aorta. The aorta is broken down into different sections, and so from the aortic valve to the brachiocephalic artery, so this section here, that is considered the ascending aorta. Then from the brachiocephalic artery to the left subclavian artery, so just this small section here, is considered the aortic arch. Then from the left subclavian artery to the diaphragm is considered the descending thoracic aorta. Now, this kind of is tricky sometimes because if someone were to ask you what are the first branches off the aorta, the answer is the right and left coronary arteries. Those are the first branches off the aorta. The heart feeds itself first. But if the question is, what is the first branch off the aortic arch, then the answer is the brachiocephalic artery. So that was confusing to me at first. But the first branches off the aorta are the coronary arteries, and the first branch off the aortic arch is the brachiocephalic artery. So again, you've got the aortic valve area, and keep in mind that blood from the left ventricle is pumping into or through the aortic valve into the aorta. Then you have the ascending aorta, you have the aortic arch, and then you have the descending thoracic aorta. And the descending thoracic aorta goes from the left subclavian artery down to the diaphragm. And then past the diaphragm, then it becomes the abdominal aorta. Also, it's important to mention, the three main branches off the aortic arch are the first one being the brachiocephalic. Oops, sorry about that. And the second being the left common carotid, and the third branch off the aortic arch is the left subclavian artery. Okay, then we get to the abdominal aorta, which the abdominal aorta, it goes from the diaphragm down to where it bifurcates. So the first ventral branch, so remember, ventral means anterior or in front of the body, dorsal means posterior or the back of the body. The first ventral branch off the aorta, in the abdominal aorta, is the celiac artery, and it's in this area here. You see it better on a lateral view because it is a ventral branch. You don't really see it as well on the AP view. So so about this area here is the celiac artery. You might see it called the celiac axis or the celiac trunk or the celiac artery, and I'll explain that here in a minute. But basically the celiac artery, it's just a small little trunk, and then it trifurcates into the hepatic artery, the splenic artery, and the left gastric artery. Okay, so inferior to the celiac artery is the superior mesenteric artery, and it's about right here on this picture. And again, it's a ventral branch, so it's kind of hard to see. Then you have the right and left renal arteries. They are lateral branches, so they are easily demonstrated on an AP view. So you got your right renal and the left renal artery. Below the renals, then you have another ventral branch, which is the inferior mesenteric artery. So the way I remember this is how I do it. For me, it's easy to see the right and left renal arteries coming off. Those are lateral branches. Those are easy. So from there, I know that there's a superior and an inferior. So the superior being the superior mesenteric, the inferior being the inferior mesenteric. And then above the superior mesenteric, you have to remember there's the celiac. So that's how I do it. Um, the abdominal aorta then descends down further and then bifurcates into the right and left common iliac arteries. Here's a lateral view of a abdominal aorta, and so now on the lateral view you can see these ventral branches. So you have the celiac axis, which again which is just a small trunk. It's only about that big, and then it trifurcates. Right below the celiac artery is the superior mesenteric artery, and then right below that are the right and left renals, which you don't see very well on this picture, again because this is a lateral view and you don't see the lateral branches very well. But let's just say that they are right here-ish, superimposed, and then below the renal then would be the inferior mesenteric, which isn't showing up on this particular picture. Okay, now we're moving on to the pulmonary artery. And the main thing to remember about the pulmonary artery is that you access it via a vein, okay, which is a little bit confusing, but let's just say that this was a femoral approach. And I'm going to use my blue pen just to signify it as a vein, and it's a deoxygenated vessel. So let's just say it's traveling up the vena cava here. Then it has to enter the right atrium of the heart, then to the right ventricle of the heart, and then up into the pulmonary artery. And then the pulmonary artery, again, is kind of a short trunk before it bifurcates into right and left pulmonary artery. So this is demonstrating the right pulmonary artery. So the catheter is placed about here and contrast is being injected into the pulmonary artery. So this picture is just to remind you, I guess, that for a pulmonary artery angiogram, the catheter goes up through the vena cava into the right atrium, into the right ventricle, and then up into the pulmonary artery. And then, so this is demonstrating it going into deep into the right pulmonary artery, and then contrast is injected. This picture is demonstrating the bronchial arteries, and the bronchial arteries, there are some variants to them. They are a ventral branch. They're small, and like I said, there's variants to them. Here it's demonstrating, one branch coming off the aorta, and then it bifurcates into the bronchioles, where here it's actually a right bronchiole and a left bronchiole. And so that's what they look like on a diagram. Here is a vena cavagram. So here we're seeing a right brachiocephalic vein and a left brachiocephalic vein. And again, that's important to know because there is a left brachiocephalic vein that does exist, but there is not a left brachiocephalic artery. A lot of times the arteries and veins, run side by side and they're the same, but this is one instance where there is not. There is a left brachiocephalic vein, but there is not a left brachiocephalic artery. So the two brachiocephalic veins merge together to form the superior vena cava. So all the blood from the head, neck, and upper extremities converges here, and then from the superior vena cava it enters the heart in the right atrium. Here's just a reminder that the walls of a blood vessel have layers. Now this diagram says artery, but it could be an artery or a vein. An artery or vein has 3 layers. First, there is the innermost layer, which is called the intima. Then there is the thicker layer, the middle layer, which is the muscular media. Then the outer layer of a blood vessel is called the adventitia. So, and then the space inside a blood vessel, that is called the lumen. So blood, as it travels through a blood vessel, is in direct contact with the intima, which is the inner layer of a blood vessel. The heart also has layers going from innermost out to the outermost. The inner layer is the endocardium. Then you have the middle layer, which is the myocardium. And again, that middle layer of the heart is the muscle layer. Then you have the epicardium. And then remember, the epicardium and the visceral layer of the pericardium are the same. That again gets confusing. So the heart is enclosed in a double-walled or double membrane sac called the pericardium. The outer layer of the pericardium is the parietal layer. So again, that would be this outer layer here. And then the inner layer of the pericardium, the inner layer of that sac, is the visceral layer. Whoops. V-I-S-C-E-R-A-L. The visceral layer, that's the inner layer. So again, the parietal layer is the outer layer, visceral layer is the inner layer, and that visceral layer is also considered the epicardium. Between those two layers is the pericardial cavity where there is pericardial fluid. And then you've got the lungs, and the lungs have layers as well. The lungs are also enclosed in a double membrane sac, and the outer layer, first of all, the sac is called the pleura. The sac that encloses the lungs is called the pleura. The outer layer of the pleura is the visceral layer. And the visceral layer lines the inside of the thoracic wall. Okay, so that would be considered this layer here. It lines the thoracic wall. It lines the thoracic cavity. So this that I'm drawing now is considered the visceral layer. Then you have the parietal layer. And you can think of the parietal layer as, whoa, I just said that wrong. Okay, sorry about that. I said that wrong. The outer layer is the parietal layer. The parietal layer is the outer layer. Sorry about that. Then the inner layer is the visceral layer. The word viscera means organ, so that's how I can remember the visceral layer is the one that's closely adhered to the organ. So the visceral layer is always the layer that's closest to the organ, and I always think of it like saran wrap. The visceral layer is wrapped tightly around the organ, and that is the inner layer. The outer layer is the parietal layer, and the parietal pleura is this outside layer that lines the thorax. So within the parietal and visceral layer is the pleural space. And of course, in that pleural space, there should be just a small amount of pleural fluid. But if that space fills with too much fluid, then it's called that is a condition called pleural effusion. Okay, well, I think that went fairly well, except for this blunder here at the end. I apologize, but hopefully that didn't mess you up too much. And you'll want to just go back and if there's any areas that you need help on, just replay the video. Thanks.